All right, this is our 2014 version of our Skywarn spotter training. As an introduction, my name is Phil Krimsky from the Weather Service, as he told you already. I've been here several years, so I've gotten to see a few seasons of our weather, and it's quite interesting. So, especially this winter. I mean, a couple winters ago we were warm, and now we're cold, and it's what happens in mid-latitudes. The Weather Service is a federal government agency. We're part of the Department of Commerce, also part of the NOAA, National Oceanographic and Atmospheric Administration. We have 122 weather forecast offices throughout the country. As you see from these little plots of land here, that's what everybody covers. So if you're lucky enough to be a meteorologist, you could work at any one of these offices. And I've worked in Green Bay, Milwaukee, and now Detroit. We also have national centers. Most of you know the Storm Prediction Center, located in Norman, Oklahoma. Here. We also have other national centers like the National Hurricane Center in Coral Gables, Florida, the Climate Prediction Center in DC, NCEP also in DC. So we have a lot of national centers that enhance us at the local level. Here in Detroit, or White Lake, we have a team of 24 professionals. We have meteorologists, hydrologists, electronic staff, fix stuff that breaks, IT personnel, administrative staff. And our main mission is to provide forecasts and warnings for the protection of life and property. We do this 24 hours a day, 7 days a week, including all holidays. So while you guys are at home opening Christmas presents, we're at work. So somebody's always there watching the weather. We cover 17 counties in southeast Michigan, all the way down to the Ohio border, all the way up north to the Saginaw Valley and east to the Thumb. And then you guys here are probably our most extreme eastern portion that we cover. We also cover the Great Lakes, including Lake Huron, Lake St. Clair, and extreme western Lake Erie. So why are spotters important to the warning process? When we issue warnings, we consider three things. We consider the environment, Doppler radar, and spotters. So if our environment is conducive for tornado development, and Doppler radar is conducive to tornado development, we see the hook and we see the rotation, and spotters are seeing a tornado, we're going to issue a tornado warning. And how we simplify that is we call it the rule of 2 out of 3, or the meatloaf rule. 2 out of 3 ain't bad, right? So if we get 2 out of 3 of these things, we're going to issue a tornado warning. If a spotter is seeing a tornado and our environment's conducive for development, we'll issue a warning. If the environment's conducive and the radar is showing tornadoes, we're going to issue a tornado warning. But the reason a spotter is important is because we will actually put that information in our warning products or our follow-up statements. So that information funnels into the National Weather Service, gets disseminated through local television, emergency management operations centers, NOAA weather radio, and now even cell phones. That information goes out to the public, and hopefully they take the appropriate action based on what information we're giving them. So ask yourself, if you get a tornado warning that says Doppler radar indicated a tornado was possible, are you going to take that more seriously than trained spotters have seen a tornado on the ground? That's why we need your reports, because that lends extra credence to that warning. So what is the criteria for a severe and tornado? A severe thunderstorm is any thunderstorm that's producing winds of 58 miles an hour or greater, and or a hail of 1 inch in diameter or larger. A tornado warning is any time we have Doppler radar indicating a strong rotation within a storm, or confirmed reports of a tornado, which is why your reports are so important, because if you're seeing a tornado, that confirms that a tornado is on the ground. We want you to report wind to us, any wind that's 40 miles an hour or greater. And generally that's when twigs start breaking off trees and wind impedes your progress. Higher than that, more bad stuff starts to happen, like damage to chimneys, shallow rooted trees getting pushed over, Eventually roofs get torn off houses and cars lifted off the ground. Report hail of 1 inch or greater. And how we measure hail is, you can get out a ruler if you want, or you can compare it to a known object, such as plain M&Ms, and then when you get above that, generally it's money. So you could either take a guess or pull some change out of your pocket and throw it on the ground. Pennies, nickels, quarters, half dollars. Then you get up to ping pongs, golf ball size hail. That doesn't mean you go outside with your club and try to hit it. And then other objects such as baseballs, tennis balls. I'm waiting for the report of DVD size hail. Or Blu-ray, I guess, right? Same size. Got hail the size of Blu-rays falling. Report all tornadoes. Tell us your location and direction you're looking. Seek shelter. And as you can see, here are 2 examples of tornadoes we've had in the last couple years. When you report a tornado, you want to ask yourself, is it rotating? Do you see debris or electrical flashes? Good and accurate reports will lead to good warnings. Bad reports lead to false alarms and credibility loss. If you keep calling in a tornado every time you see some gnarly looking clouds, and then you really do see a tornado, what do you think is going to happen? So if you're not sure, wait and keep watching. And provide frequent updates. You know, you can say, oh, I see a funnel start to descend, and oh wait, it's on the ground now. Oh, now I see it's lifted. So that's good to tell us because that says, okay, maybe the threat's over. Report flooding. Generally, it's longer time over the winter, shorter time over the summer. So anytime we have an inch or greater in a storm, generally 12 to 24 hours in winter and a couple hours in the summer with thunderstorms. Any flooding that covers roads or threatens property, such as river flooding and ice jams. So with all this snow we've had, if we get some really good, heavy thunderstorms that melts all that snow, and because the ground's frozen, it's not going to soak into the ground. So the heavy rain will combine with the snow and just run off and create a lot of flooding. So with everything that's happened this winter, we're at an elevated risk for some flooding and ice jams. Hopefully, like what today, you know, you just had some sun and 50 degrees and it melted slowly. That will lead to less river flooding than a huge thunderstorm that just dumps several inches of water on us. Reports post-storm damage. So let's say you get home, you see something like this. Tell us about anything that happened after the storm, such as large tree limbs down, power lines, structural damage. And the reason it's important is we do damage surveys, as you all know. So let's say we have reports of tornadoes happening and your neighbors aren't as good as you because they don't report damage. You may be the only one in your neighborhood that reports. So let's say we're going along our business trying to figure out whether a tornado touched down and where it lifted and nobody in your neighborhood called. We're not going to come there because we're not sure, or we don't think it stopped there. So by you calling in, that tells us we need to check out your neighborhood to see if there was tornadic damage or what kind of damage occurred. It could be straight line or whatever. So even after the storm, it is important. Don't think, well, they must have gotten this report for sure. It's better to have 2 reports that are the same than none. Report funnel clouds. And this is a rotating column of air that is not in contact with the ground. And you notice here, there's no little debris swirl. That's a funnel cloud. Now, if there was a debris swirl, that would be a tornado, even if that condensation funnel does not go all the way to the ground. As far as how to report, those little cards I gave you should have all that information on there. So first way is toll-free spotter hotline. It's unlisted, and like I said, we're there 24 hours a day. Please only use that for spotter reports, even though we're working midnight on a Christmas Doesn't mean we're lonely, we want to talk. We got work to do. That also doesn't mean you just call in, hey, I saw the latest GFS run come in. You going to issue a winter storm watch? Yes, we saw it, and we'll do what needs to be done. Another way, amateur radio, local nets, MyCon. You can also use the internet, Facebook and Twitter. The great thing about Facebook and Twitter is you can attach pictures. So not only can you tell us what happened, you can show us what happened. And that's really handy, especially for, let's say, a tornado. And we're not sure, and you take a picture and we say, oh yeah, there's stuff on the ground being lifted up into the cloud. Or let's say you take a picture of hail and you throw some money down there and you take a picture of hail with money. Oh yeah, that thing's bigger than an inch. So social media is really powerful for getting those reports. And plus, if it's a really good picture, you might see it on our website later on a post-storm damage summary. So you can tell your friends about that you're really cool. We also have Packet Radio. eSpotter has been discontinued. There's going to be a new website in the works, but it hasn't been determined what that's going to be yet. So when you report, we want to know your location, your city, your closest major intersection, or you can just give us your lat long, I suppose. Tell us what you're seeing, and if you are reporting wind or hail, tell us, is it measured or estimated? The time the event occurred, and any damage. So for example, I might call and say, hi, I'm in Port Huron. I'm at Grand Avenue at the county building. I'm seeing 1-inch hail and estimated 60-mile-an-hour winds because I see branches getting torn off the trees. I estimated the hail based on, just based on the size of a quarter. And the event is occurring at 7:27 p.m. And the damage was, I saw trees, limbs getting ripped off the trees and it hit a car or something. So the more details you give, the better we are to ascertain what's going on, instead of just like, I see a tornado. Okay. So the acronym we want you to remember, tell us what happened. Time, event, location. It's easy to remember, right? So it's quiz time. Spotters should submit reports where? A, B, C, or D? B. B, bravo, right. Which weather phenomena has caused the most deaths on average over the last 10 years? C? It's C, heat. Come on, global warming, come on. Actually, if you look, these are the weather fatalities, and this is all the phenomena. Flooding, lightning, tornadoes, hurricane, heat, cold, winter, wind, and rip currents. So there's heat right there. The most weather fatalities. Thunderstorm safety for lightning, you want to stay indoors or in your car. And does anybody know why a car is safe for lightning? I saw the young man right there. Huh? Nope. What? Your car actually acts as a Faraday cage for the lightning. So when lightning strikes your car, it spreads out and goes to the ground. Your couple inches of rubber there doesn't do anything. In fact, there are several pictures on the internet showing the lightning can jump from your wheel well down to the ground. If that little bit of rubber stopped lightning, then people wouldn't get struck by lightning because they're wearing shoes. So what happens is, because your car is all wet and lightning hits it, it's a way for the lightning to get to the ground. So it spreads out and goes to the ground. So lightning, again, stay indoors or in your car. Don't shower or use corded telephones. Cordless telephones are fine, but not corded telephones. Cell phones are okay too, as long as they're not charging, because, yeah. Don't take shelter under a tree or pavilions. Lightning tends to strike the tallest object, so I suppose if you're with me, you'd be okay, right? Flooding, turn around, don't drown. Hail, don't run outside to measure, wait until the storm passes. I actually have a picture of a guy holding hail, and there's hail falling. Not the brightest thing to do. And the reason for that is you don't know how big the hail's going to be. I mean, I've seen cases where the hail falls for several minutes, and you're like, oh, this ain't so bad. And all of a sudden, you know, ping pongs, and then tennis ball starts falling, and yeah, that's not good for anybody. For high winds, you want to stay in the center or interior part of a building. Be aware of downed trees and power lines after the storm. Tornado safety. Go to your basement and get under something sturdy. If there is no basement, get to a interior room with no windows. If driving, pull over and find a sturdy building. You want to protect your head by getting low and covering yourself with pillows and blankets. And you want to stay there until the threat is over. Now, remember I said cars were okay for lightning safety? Cars are not okay for tornadoes. Does anybody recognize this car? Somebody over here said it. That's right, Tim Samaras' car, Chevy Cobalt. They were driving on the north side of a tornado, which is not smart to do to begin with, but tornado's doing this, they're driving like this. They think the tornado's going to keep going. It took a turn north. And what actually had happened was it picked up the car. It took his son and the other guy, Young, threw them out of the car several hundred feet away. Tim Samaras was strapped in the driver's seat. Unfortunately, the tornado picked the car up and went like this, several times. So as you can imagine, he didn't survive that. So that's why a car is not a safe place to be during a tornado. And these guys knew what they were doing. They were storm chasers with many, many years of experience, and they still ended up perishing. So that's a word of caution. I know a lot of young people are like, oh, this is going to be so cool. I want to go storm chasing. And even experienced people can die from it. So it's nothing to take lightly. The products that we issue out of our office, we try to give you a heads up several days in advance. So let's see, what's today, Monday? Let's say that there's a severe weather event we're expecting during the weekend. So Wednesday. That's snow, that isn't, we're talking thunderstorms. So let's say we're expecting a severe weather outbreak for this weekend. We'll issue an outlook saying we're expecting severe weather this weekend in the central and western Great Lakes. So a pretty broad area, pretty vague in the wording, but we're letting you know something is brewing. Let's say it's Saturday, the environment looks conducive, got a cold front moving through, so it looks like we can generate some thunderstorms. And let's say said thunderstorms are popping up over Wisconsin. So the Storm Prediction Center will issue a watch several hours before the event crosses Lake Michigan. It'll be more specific with the area, threat, and timing. So let's say the Storm Prediction Center issues a severe thunderstorm watch for southern lower Michigan through midnight. So that's more specific. It's a severe thunderstorm watch. They could also issue a tornado watch or PDS tornado watch if something really bad is going to happen. As the event unfolds, and let's say the thunderstorms are now over southeast Michigan, we're going to issue a warning which for this case we'll say is going to be a severe thunderstorm warning. Be 10 to 60 minutes in advance. Be very specific with the threat area and timing. That warning may sound like this. There's a severe thunderstorm warning in effect for St. Clair County through 7 p.m. You can expect hail 1 inch in diameter or 70-mile-an-hour winds. Storm is expected to hit Port Huron at 6:45 p.m. So again, that's very specific. So as we get closer to the event, as the event unfolds, our area of concern becomes smaller and smaller, and the wording we use becomes more and more specific, and our timing becomes better, rather than say this weekend, this evening, within the next hour. One of the things that rolled out last year in a project that I've been intimately involved in is called impact-based warnings. This was an experimental product rolled out on April 1st, and it wasn't an April Fool's joke. But it expanded from the Kansas and Missouri offices out to all of Central Region, which includes everything out through Wyoming and Colorado, and east to Detroit and Kentucky. What this project entails is provide valuable information to the media and emergency managers on how to improve the public response and decision making during severe weather events. One of the things we wanted to do was to meet the society's needs for the most life-threatening weather events. One of the areas that we saw was lacking was tornado warnings. In the past, if a tornado was bearing down on St. Clair County, if it was a weak, quick spin-up, or if it was a large EF4 that's going to relocate you to Canada, what would we issue? A tornado warning. And would you know the difference? Probably not, because we didn't really hype up or enhance the wording at all. So that was a major shortfall in our warnings. People were like, well, it's a tornado. Is it a really bad tornado? Is it going to shift my foundation or relocate me? What's going on? One of the things we did was create these little tags, and the tags are on the bottom of the product. They give you a better idea of what's going on. Remember our warnings before? They just went on and on, like, you know, radar indicate a storm, doing this, doing that, it's going to hit here, there, and everywhere. And so if your first question was, is it really on the ground or is it radar indicated? Well, get out a shovel and start finding it. This way, it's right there, very at the bottom of the text. See? These little tags at the bottom. Radar indicated or observed. Quick and easy. You can find it in 2 seconds. As far as the damage threat tags, if it's just a regular tornado warning, you will not see a damage threat tag. If you see the considerable tornado damage threat tag, that means you have a really big tornado that's bearing down on you. Again, credible evidence that a tornado capable of producing considerable damage is imminent or ongoing. Something like this may occur once a year or once every couple of years. It's not something that happens all the time, and that's good, because when you see it, you know that we mean business. So when we see that, you should know that that's something enhanced and something bigger than the normal tornado. We want to talk about the catastrophic tag or tornado emergency. This is a severe threat to human life and catastrophic damage from a tornado is occurring, and will only be used when reliable sources confirm a violent tornado. This is the one that's going to shift you to Canada. That's going to be your big, huge wedge tornado bearing down on your city. The only one I can think of is the Beecher tornado, the EF5 that occurred here. As far as something occurred more recently, but not here, was the Oklahoma tornado. You had that EF5, the Greensburg that wiped out that city. So that's something as a meteorologist that we may issue this maybe once in a career. I've been a meteorologist for 15 years and I haven't even thought about issuing that. I can think back to several times I would have done this, but never this. So that's something, if you see that, then you really better take that 100 times more serious. That's when there's credible evidence of a very large tornado that's going to hit you. So we're not going to throw that out there just to get your attention. That's something very serious. Severe thunderstorm warnings also are going to have a tag, and it's called tornado possible. That's if we have a severe thunderstorm that has some potential for producing a tornado, although our confidence is not high enough to issue a tornado warning. So let's say we have a severe thunderstorm, and it has a little bit of rotation in it, but it doesn't really look very strong. Maybe there's kind of a hook forming, but it doesn't look that great. We may issue a tornado possible tag on that because there's nothing to indicate that that is producing a tornado or that it's imminently going to produce a tornado. But there's still the possibility, because let's say the environment is ripe for tornado development. Well, we're not going to issue a tornado warning in every single storm that pops up. It has to show us that it's producing a tornado. Or you could see a tornado. Again, the 2 out of 3 rule. So when you see this, you know to be a little extra vigilant. It's not your run-of-the-mill severe thunderstorm warning. You know to watch out for any possible tornadoes that may form. How to get weather information? You can go to our website, weather.gov/Detroit. You can get warnings, forecasts, radar and satellite imagery. Just go to our map here, click on Port Huron, and much to your dismay, when you click on it, you'll see this thing that says Winter Storm Watch in effect. I'm sorry, I didn't issue it. You can go to the Storm Prediction Center website, and you can get the convective outlook. See, we have green here for general threat for thunderstorms. We also have yellow for a slight risk, and then moderate risk is red, and high risk is pink. You can get mesoanalysis if you're a really big weather geek and you want to see some of the stuff we're looking at. You can click on your area of interest, see how the Cape's building up, check out the precipitable water, the shear, all that good stuff that a young budding meteorologist would look at. Get information from local television and radio broadcasts. You can view polygons on TV, so let's say you're in the southern part of a county. You can see that the tornado warning is in effect for the northern part. You can get weather radio broadcasts, which will give you the weather, observations, warnings. And for you boaters out there, it'll give you the boating forecast and any marine warnings that are in effect. So hopefully you don't head out if it's a bad day for boating. You can program it for your county for specific hazards. You want a battery backup for power outages, and will also tone alert for warnings when not in use. Anybody who has a smartphone is getting these wireless emergency alerts. And basically that's free to the public, uses your cell tower to alert people for tornadoes, flash floods, hurricane warnings. And you're automatically enrolled, but you can opt out if you want to. Don't ask me how, every carrier is different. Some you have to log into the website and say, I don't want to get this. Check with your provider about service with your phone. I know it works on mine because I've gotten tornado warnings on mine. So in order to get any of this stuff that we're talking about, tornadoes, severe weather, we need a thunderstorm. In order to get a thunderstorm, we need 3 ingredients: moisture, unstable air, and some sort of lifting mechanism. When you have those 3 things, you can get a thunderstorm. The basic parts of a thunderstorm: you have your flanking line, your main storm tower, your anvil, modest clouds, your rain and your hail. The area to the left is going to be your updraft or inflow area. This is where stuff is going up. Your downdraft area is where stuff's going down. This is where your outflow is going to be. in the forward flank of the storm. Thunderstorm types, just like people, we have all different kinds of thunderstorms, ranging from the single cell to the supercell. The single cell has a weak, brief updraft. It can be severe or non-severe and is a slight threat for brief, severe weather events. And the single cell kind of looks really small, like a little lonely cell. A multi-cell cluster is a cluster of storms, just like it sounds. The multi-cell line is a line of storms. These have moderate updrafts. They can be severe, they can be non-severe. It is a moderate threat for brief or sustained severe weather events. So these are the ones that could go on for a long time. Supercells, those have intense rotating updrafts. Those are a high threat for long-lived severe weather events. Those are the really bad ones. So if we look at this chart here, these four pictures, let's try to identify each thunderstorm that we see. What do you think this one is here? Multi-cell what? Cluster or line? That's right, it's a line because it's, well, it looks like a line. What does this one look like? Single cell? Boy Scouts are doing good. What is this one down here? Nope. Supercell. See that little thingy down there? That's a tornado. Also notice the striations in the cloud. That's a sign they have a intense rotating updraft. Anybody like ice cream? What happens when you make ice cream and you rotate it? What happens? It has striations on it, right? Same concept. Oh, sorry, multi-cell cluster, the last one. There's only one left. The life cycle of a single cell has three stages. The towering cumulus stage, where everything is updraft. This is when it's just forming. The mature stage, when you have an updraft and a downdraft. And then the dissipating stage, where it's all downdraft. Here's three pictures. Developing. Anybody ever see a thunderstorm pop in the afternoon? That's your developing stage. That's when you see it go. It's really kind of cool. Mature stage. That's when you get your anvil, you get your rain falling out of the cloud. And then finally, your dissipating stage is when everything is down and it's dying. Let's take a look at a single cell on Doppler radar. And I'll let this loop a few times. So what's one of the things you notice? See how it pops up, does this thing, and then goes bye-bye. What's this little thingy that comes out of here? Hold on. It's coming. Yeah, what's this? Gust front. What happens when the gust front pushes out from that storm? What happens to the storm? Yeah. You know why? When the gust front pushes out from the storm, it's kind of like kicking your legs out from under you. It doesn't have any way to get that unstable air back into the cloud. So when the outflow pushes out from the storm, the updraft is cut off, so the storm dies. A multi-cell cluster will have all three of these stages occurring at the same time. Towering cumulus, mature, and dissipating. And the reason this can be so dangerous is if you keep getting formation upstream, this thing can go on for a very long period of time. Here's what it looks like towering cumulus, new growth, strongest thunderstorm, and then your oldest and weakening thunderstorms. So we'll take a look at the multi-cell radar animation here. What's one thing you notice? What's happening up here? Yeah, regeneration. What's happening down here? Yeah, they're dissipating, and then those poor people in Flint are getting the brunt end of the rain, which means they're getting flooding. So if you have regeneration over the same area over and over again, that's basically someone just keeps pouring buckets of water on you, and that's not a good thing. So a multi-cell line or squall line is when you have severe straight line winds with a shelf cloud on the leading edge. The shelf cloud will point down and away from the main precipitation core. Here's your precipitation. See all that bad stuff? It's sloping down and away. This is a sign that you could have widespread severe weather and straight line winds. When you do see this, that's indication that you have straight line winds because something's pushing that up. It's not magic, it's the wind. A schematic of a squall line. You say you have a line of storms, and if your gust front, I didn't think it was that bad. If you have your line of storms and your gust front stays coincident with the storms will be okay. If the downdraft pushes out ahead, the gust front pushes out ahead, it'll kill those storms off. So here's your updraft, here's your downdraft, here's where the shelf cloud's going to be. So see if the downdraft pushes out over here, then this gets cut off and the storm dies. So we'll take a look at a radar information from a radar loop from June 18th. We'll let it loop a few times. Notice in the beginning, gust front stays pretty much with the storms, everything's fine. And then look, pushes out ahead and what happens? Goes bye-bye, yeah, and dies out. I want to caution you though, when this happens, it doesn't necessarily mean the severe weather threat is over. I've had instances where I've seen a squall line form and that gust front pushes out ahead of the storm. It's like, okay, everything must be fine, I'll stop issuing warnings. And I was like, oh, I got a tree down. And it was this thingy out here, still pushing over the trees. So that's an instance that's very dangerous because a lot of people, because we're people, will wait for visual clues or clues of stuff falling on our head like rain or thunder. We'll wait for that before we do anything, just like the tornado. Well, we have a tornado warning, I'll wait till I see it or I hear it. Well, we may have a warning out for straight line winds and people are like, yeah, I'll wait for the rain or the hail to start and then I'll take cover. Well, if this is happening, you won't get any of that. That gust front will push through, knock over your tree, and you'll be like, there's no big thunderstorm, what happened? This happened. And I've seen it happen a couple times, so it's not anomalous, it can't happen. Supercells have many of the same characteristics as regular storms. However, they have additional things such as back-sheared anvils, overshooting tops, wall clouds that point down and towards the precipitation, not down and away. A rain-free base where the updraft is, the downdraft where your rain and hail is, and this is where your shelf cloud's going to be. One of the main differences in a supercell is it has a rotating updraft. And there's your downdraft area. So the reason why you have an overshooting top is your atmosphere is unstable up to here. Past this, it's stable. But your updraft is so intense it actually punches through that stable layer. It kind of gives the atmosphere an uppercut. And And it doesn't care that, hey, I'm stable, you can't go past me. It's like, I don't care. Now it doesn't go on forever because it's stable, but it does produce this little overshooting top. So that's a sign that, hey, this updraft is so strong it pushed past the stable layer. So that's another indication that your storm is really strong. Your rear flank downdraft will wrap around your updraft and create your famous hook echo that you see. Looking down on the storm, here's your precipitation core. Here's your gust front, your forward flank downdraft. That's where your shelf cloud's going to be. Your rear flank downdraft's going to wrap around the updraft, which is here, and create your little hook, as you see on radar. And then here's your flanking line. If you look at supercells, they come in all shapes and sizes. Doppler radar view. Again, your hook, your RFD wrapping around the updraft, and there's the RFD here. Doppler radar, again, I said, detects things moving towards and away from it, so when you have really bright green and really bright red next to each other, you're getting this going on. Here's an example from March 15th, 2012. Does anybody remember that day? Yeah, what tornado happened? Pretty big one. EF3. Dexter, that's right. What's one thing you notice? This is reflectivity. See the hook? Right before it hit Dexter. That's why we were able to issue that tornado warning so far in advance. This is something that I would have probably issued the considerable tag for had we had it in use, because it looked bigger than a regular tornado. And it would produce EF3 damage, so that would have been absolutely correct. Here's another one from May 28th, 2013. This is Flint. Let this loop a couple times. All right. Let's watch the storms coming up here. Here's one here. See? There's a hook there. And there's another one there. This was kind of a, there's another one there. So this wasn't an easy day for warning, and they relied less on reflectivity and more on the velocity, because they were looking for the velocity couplets showing rotation. So what is the main difference between a supercell and the other three types of thunderstorms? What makes a supercell special? Huh? Yep. A mesocyclone or rotating updraft, that's what makes it different. Let's say we had a tornado watch. What type of thunderstorm would you expect? Severe. Now, what type of thunderstorm? Somebody did that in my last talk. Yeah, yes, it would be severe, but what type? Yeah, supercell, right. Shelf clouds, again, I said they were the leading edge of the squall line, sloped down and away from the precipitation. The strong winds will occur along and behind the shelf cloud and is a visible warning that you're about to get straight line winds. Wall clouds, isolated lowering the rain-free base. In a supercell, slopes down and towards the precipitation and indicates the possible location where a tornado could form and will often exhibit signs of slow churning rotation. Doesn't mean it's going to happen. I've seen plenty of wall clouds that didn't do anything. I've also seen funnel clouds that didn't do anything. Getting a tornado is actually pretty rare. Tornado is a violently rotating column of air extending from a thunderstorm and in contact with the ground. The funnel cloud is a rotating funnel-shaped cloud extending from a thunderstorm base but not in contact with the ground. Now, if we would have had a debris swirl down here, would that still be a tornado, even though that condensation funnel does not go all the way to the ground? Yes. Here's video of the Dexter tornado. This is not the actor. This is why Facebook is so handy. I found this guy on Facebook and said, "Can I have your video?" He said, "Sure, if you're going to use it for the spotter training." See how much that storm is churning? It's picking up stuff down here. So again, I said I would have issued a considerable tag on this because look at how big this thing is. It's not your average tornado. It's a little bit bigger than that. Little thingy forming over here, isn't there? Yeah.
Is that moving parallel with the road? It's not coming out.
Looks like it's kind of moving towards them because it really hasn't moved much.
I guarantee that to be
It's starting to rope out, yeah. So one of the biggest challenges people have is seeing tornado lookalikes. So a challenge is determining whether you're seeing the real thing or a lookalike. Two key features are present with a tornado: debris cloud near the ground and organized rotation about a vertical axis. When you get that, you can have your tornado. And the rotating tornadic condensation clouds will be fairly smooth, like this. Many lookalikes will have a more ragged looking appearance, and they won't be really rotating. They'll be doing some funky stuff, but they won't be rotating. The difference between straight line and tornado wind damage: the trees will fall in different directions with some convergence. With tornado damage, straight line winds, it'll be like a big splat. And one damage survey I went on, I could actually see the middle of the tornado because I was walking and everything was in one direction, hit the middle, kept walking, everything was in the exact opposite direction. So there was a convergent pattern. So that's one reason you know you're looking at tornado versus a straight line. A straight line, everything would have been in one direction and kind of fanned out. So let's say you walk outside your house and you see this. What would you report? Only report what you see. Tell me what you're seeing.
Tree down doesn't look like it came, like it was just knocked over. It came from something was lifted it.
Yeah, it's a tree limb down. What do you report if you see this, other than somebody lost 41 cents? Yep, quarter size hail. Again, you report the size of the largest hailstone. If you see this, what do you report? What? Anybody else? Would you report anything? No. Report nothing. While lightning is dangerous is not criteria for severe weather. That's a cool picture you could post to our Facebook page. but it's not worthy of a report. If you see this, what do you report? Flooding covering the roadways. If you see this, what do you report? Yep, funnel cloud. There's no debris swirl. So the top 6 most important things to report: tornadoes, waterspouts, and funnel clouds, all weather-related damage, wind gusts over 40, hail, plain M&M size or larger, or if you like me and you like peanut butter, I guess Reese's Pieces are larger, right, to the same size. Report winter weather. We're not done with that. As you saw, we have a watch out. Flooding that threatens property or covers roads, which we may see, especially with all the snow we've had. Does anybody have any questions? We're all done.